Hey everyone, good morning. What did we do in the last class? We did CNN implementation. Did you run your model for more epochs? Did you run model for more epochs? No. Until you run, you don't get to know like how well it performs. Today, I'll show you one more project. And this week project will be based on the same thing. So I have uploaded task already. It's a potato leaf disease detection using an image classification. Project description is given, objective is given. So you have a three classes. Like usually potato leaf will have certain diseases, okay? Early blight, late blight, and a healthy leaf. So this basically helpful in agriculture to understand which leaf has a disease and which disease doesn't have. So using sensor, so basically they can detect it and accordingly the pesticides can be given instead of giving the same pesticides for all the plants. Okay, just focusing on the one. This application helps in focusing on a leaves that basically has a diseases. Okay. And the code to load data set I have given a Kaggle, you can download and you can do it, or else I have given a code in order to download from a Kaggle hub. If you want to follow the process that I'm using, you can just go with this. Use this code, it will download our data, and then load and explore, visualize your data, do data pre-processing, such as we did now, rescale, that is normalizing, shifting, rotating, zooming, apply all those data augmentation and then build CNN model, use a different layers of CNN, different layers of pooling layer, and then train your model. Train it for at least 50 epochs and see how well your model performs. If not 50, at least for 30. And then along with training, make sure you validate your model, use a validation data set, and then test the overall model performance. Finally, evaluate the model using accuracy or confusion matrix, or you can use a classification report as well. And then record a video for 15 minutes and just showcase like what you have done. Here, it's already in a drive. You can refer to it and you can do it. Today we'll do one more, so you will get an idea. But you have to wait with the patience to run your model for multiple epochs. Just run and do some of the work so it will finish the task. So running for just 5 epoch, 10 epoch will not make sense. Since it's taking time in a class, I'm using only like few epochs. Even that also taking time, right? Yeah. So we'll finish. We'll do one more and we'll move to the NLP from tomorrow onwards. We'll discuss about NLP pre-processing steps for Thursday, Friday. Next week, I'll discuss about NLP models like Naivibase, RNN model, LSTM, group, and also we'll discuss about attention mechanism, encoder, decoder, and also transformers. And we'll do projects based on that. And then we'll start with a generative AI. Before that, I want to show a deployment, how it works. And then we'll start with generative AI. Okay. Yep. I hope it's clear related to our task. Any questions, you can reach out to me. So just launch a new collab notebook. So now we'll just take up our data. Similar to handwritten digit, you have handwritten alphabets as well. You can try that. And then what shall we pick it up? We'll use this brain MRI images for brain tumor detection. You have just two classes, S, no. We'll try this. Okay. You will find this data. I cannot share our link. Brain MRI images. Or else you type looking into this. Or else just search for it. Just go to our Kaggle ones. His name is Navonil Chakrabarti. You can type his name or else you can type the same thing. Wait, I'll give you like path name so it will identify. And 40 MB data might be wrong, maybe a longer one. Just do one thing. Just go to our data sets. Okay. Click on our computer vision and click on most hosts. In this, you will see it. Brain images for brain tumor detection. You found? Did you find?
Yes, ma'am.
Okay then.
Yes, ma'am.
Great. Just load the data then. Done loading. What is the next step? So so load data set is done. Now we have to see the directories available in us in that particular thing, right? List directories. I mean, list subdirectories in a path. subfolder kind of thing. Just import OS and then print OS dot list directory of your path. Okay, we have three things, just SNO and brain tumor dataset. What is that brain tumor dataset is representing? Maybe some text kind of thing, something might be there, but we can see only two now here. Okay. Even you got three?
Yes, ma'am.
Okay.
Yes, ma'am.
So what next? So we have to visualize. So we'll take up only these two folders. I don't know what is within this brain tumor data set. We'll see. We'll explore one by one. We'll use a for loop for class name and okay. So we'll create a path for class name. So OS dot path dot join. You have to pass your path as well as your class name. So here they'll just call it like a class path. Okay, this is a class path. Let's try doing something like, let's create a path and let's try to simplify it every time calling this. Okay, we'll do something else in a different way today. So we created a class path. What next? Now I'll use for X in class path. We'll try getting images. How to get an images? For X in class path. Now I have to loop through each class path. So for X in class path, if I try to print X, okay, so Okay, that is just taking S no. We have S folder and we have a no folder. This is just like a normal one. Understanding? So here for every folder, I'm creating a path. Creating a path for each folder and coming here, I'm looping through each class path and each class path has a values like S no. So we'll try creating image path for them. Let's call image path equals os dot path dot join. I have to call a class path. Along with that, I should pass my image name. And let me try to print an image path now. Okay, great. Did you understand this step, what I did? Creating path for S and no. Okay. So now, basically S and no images.
Işte. Benim işte.
So here creating path for S no folder. I'm just making it simplified. S no folder, all right. Okay. So next thing, I want to loop through all the images. Loop through all images. For image one, this is class path. I got it like S name. Then looping through this class path, again we got like this. Mm. Can you see the images? We have just no only. So for class name in os.listed, okay, path. We're creating a class path. Done. But I'm getting all the, I'm not getting all the images, only nose I can see. Three, two, two. Okay. Just a minute. Okay, but we use the same logic now, but still why it's not giving S labels? But to join class name, class path we created. And then we are looping through directories of class paths. So created image path, os.path.join. Okay, anyways, instead of finding it separately, let's try to club it together, and then you can expect to get our results. Okay, we'll go with the old approach only. So here basically you found the class path, that is like path for your folder. I'll just hide this. And then if os.path.ease directory, that means if your class path exists, so I'll be taking an images. So when I say images, I'll call os.list directory. I'll pass a class path, and I'll be taking five images in each. And then let's use a for loop. If you want, you can just try printing images and you can see. So print images. So you should get 10, five images from SN. Yeah, it's working. Extra, it's giving label SN. No, I know what is. Okay. And then I'll just use for X and images. For X and images, let's create an image path. So image path equals. So it's os dot join dot path, your class path. As well as you have to pass your this you can change it to image instead of X. You can change it to image. So you can just see instead of names, you will get a path. Sorry, it's a path.join. Can you see? So total is 10 because 5 from S, 5 from no. Tumor means S, no tumor means like no. Okay, since I'll be running my loop for multiple times, I'll just use I equals 1. And you can just use plt.figure of Size equals 5,2. Import matplotlib dot pyplot as PLT. And from Python image library, just import an image. Okay. Yeah. So after getting an image path, basically what you have to do, you have to load an image, right? How do you load image? So just use image equals image dot open, pass your path. Image dot open, pass your image path. That's it. Then just use plt dot subplot. So only 2 rows in each row, like 5 values, right? So I'll say 2 to 5. And then I. Title will give a class name. And then plt dot access will put it off. And then I plus equals 1. And then plt dot tight underscore layout. And then plt dot. What happened? Error is a directory. Is it an open only image dot? Yeah. I must do one more thing. That's a small O itself. So you have to display image, right? So it's plt dot imshow. And then you have to pass your image. Hope it works now. 21 is a directory. Yeah, S is a directory. What's wrong with this? Just a minute. It is displaying, but just saying something wrong. Wait a minute. So sometimes basically what happens, no? So image folder can have things other than images as well. That's the reason it is failing to open here. So you need to write one more logic once you create a path. Just check if it's a file only, then open. If it's a folder, don't open it. Okay. So here I'll write one more logic after image path. If Just add one more if condition if os.path is file. If it's a file, if your image path is a file, only then you have to open it. Adjust the indentation. It too tight and it's going out. Okay, now it's working. Can you see? So just do that small change by adding a if condition. So sometimes even inside your image folder, there can be certain subfolders as well. So you can take only images in such case. You can take only images. Here, understood. Can you see the images? You can see this, the normal brain image, but here you can see the tumor. Okay. Hope it's clear. If this is done, now check how many images are there in each folder. So how do you check how many images are there in each folder? We'll take these two and we'll try to count it. Done? Is it showing? So you have some colorful images as well. So here we are looping through our main path, giving a path, and then we're checking if path exists. We have to count it. Just count equal towards dot list directory. Just need to pass your class path. Finally, let's try printing. So that was a brain tumor data set it is showing. Try printing inside. Yeah, and just use a length function. So previously I was printing class name and account outside a function. I mean, outside a for loop. So it's a very small data set. You have like 155 images related to tumor and 98 images related to node. And this is brain tumor data set. Like we have a two folders, something like that. Okay. Clear? What next? What should be the next procedure? So try creating data frame to load all the images and labels. You know, right? You did for the last program. Same way, do it for this. I mean, for the previous one, handwritten digit. Create data frame and the labels. Done. You have to create a label, image path as well as a label. I guess you can make use of this entire code. Data equals p dot data frame. CRDF. Columns equals image path and labels. Oh, what's wrong? Just giving image path. Sorry, I'm appending a string here. Sorry. Yeah. Yes. But the thing is, here we selected only 5 images. Now you just remove that. Select all the images. So almost like 253 we have. Yeah. It goes like this. Done, Cleon. Did you create? Just take a break and then we'll continue. You people are back.
Yes, ma'am.
So we got our data frame. What next? What did we do apart from this? About height and width. We'll just do something like already we have a code. Now we'll just customize according to our code, according to this data set. So shuffle it. When I see shuffle data, so I'll just call data because it's not a DF. You can see yes, no shuffling has happened. Great. Next, you have to split data for training and testing. Again, same thing, 70% for training, validation, 15%, testing, 15%. Instead of DF, you can just use a data. You can copy from your notebook and you can customize. See? 177 taken for training, 37 taken for test, and remaining is taken for 39. It is splitting according to how much data it has. Okay. Just finish this and let me know if done. Done. So after splitting data for training and testing, next important thing, just check the height and width of an image, and then we'll do the pre-processing. Image, so it's a short form. Well, it's 234 and 215. Done. Next step, input all the things related to TensorFlow, TensorFlow STF, TensorFlow from Keras, Keras from TensorFlow, and then image data generator. And then define your batch size as well as our image height and width. So in this case, what should be the height and width I have to keep it since it's 234 and a 215? So basically for fast training, we use 128, which we used in our last class. If you want a best balance, like if it wants to capture like clearly, so since it's a brain image, so we'll just go with a 224. Okay. Just change the image height and width. And then rest all normalization will remain the same. The same thing, do it on train data. Change image path and the labels. Change the spellings according to what you gave. Same way for test. Change here to test data. That's it. Same for validation. And just change your validation data. That's it. Do these small changes and let me know once done. Done. So what next? Okay. Once you clean your images, the next important thing, you have to see like how many inputs, how many batches it is going to create. Anyhow, it's a small data, so probably we can expect a better results. So this is just a validation generator. Okay. Well, it's only 6 batches because we don't have much images, only 32 images per batch. So it will be a bit faster. And the next important thing, let's just import layers, models, and all. We'll define different layers. So here the number of classes should be like how many? How many classes we have to use? And also what should be the loss I have to use? So it's a binary cross entropy. And then the number of classes should be 2. We have just S, no concept. Okay, and rest all here, like since it's a binary classification, you can just use a sigmoid. Rest all can be the same. And then just compile it. You know what happens with compiling? So we'll be using categorical cross entropy. Metric will be accuracy itself. Cross entropy is not defined. Okay. Well done. Finally fit it. You know how to fit a model? So train generator will be using validation generator and also verbose. Since a smaller data will train for 20 epochs, still we have a time. Okay. And this validation generator, I'll just call it like a validation. Verbose equals 1, done. What's wrong? Hence 4 is compatible. Mm, just a minute, let me check. Okay, I did have a small mistake. You know what is that? Can you guess the mistake in this code? Can you guess the mistake in this? So what was our image size? What is the height and width we took? 224 now. Since I'm copy pasting, I'm using 128 itself. When you copy something, you should know how to debug it. Well, now it will work. So it was not matching with an input, so it took time. So now it will evaluate, it will be faster, just like 2020. And then you can find overall model accuracy, train accuracy, and a test accuracy. So you can try up to 50 something, like you'll get a better results. And also I'll show you the graph, like how things are going to vary today. Yeah. And also if you want to make specific prediction, you can just use this code. If you didn't type, at least open my notebook and just run my notebook. I'll upload into a drive. It's not 27, it's 28. Yeah. Say so faster. The accuracy score is increasing, training.
बरोबर.
Good, but still we can improve now. Just a 15 more minutes. Let me try with 15. a bit of overfitting as well. You could see some certain jump and down. Can you see finally after 40, like it's improving? So more you train, your model becomes better. Still, it's dropping. There is a lot of fluctuation. Anyhow, it's a small data, so it happens. Overfitting model is too complex, and the data we provided is very less. Almost done. So in this image, basically there is a tumor. So I'm going to save this image. Let's use this for making prediction. I'm saving it as JPG. Okay. So almost done 50. Okay, 79, not bad. We'll try with overall. Okay, it's 79. Training accuracy as well as a testing accuracy. Not bad. It's a good. It's not overfitting. Doing well. Still, you can try up to 100 or 150 or 200 epochs. You can try boosting the performance. It's possible. Okay, that's still okay. See, this is how the graph is showing because there is a fluctuation, increase, decrease kind of thing is happening. Usually, as we increase the epochs, the accuracy should increase. As we decrease the epochs, the accuracy should, I mean, like for as we increase, accuracy should increase and loss should reduce. Okay. But we see a lot of fluctuation. That's the reason you can see kind of seasonality kind of thing you can see here. And then you can actually make a prediction. You can just upload. I showed now just now. So save one of the image. I took a tumor image. I don't know where I said. Okay, it's here. Okay, and this is a code I'll be using. Yeah. So simple. We are taking an image from Keras and passing an image path, whatever we uploaded, it will load and it will resize to 224 because that's our input, right? 224 was the input we took, right? Let me check once. Yeah, 224. And then finally it converts to an array format. It will do the normalization, simple normalization. It creates a array and then it will be sent to the model. So it's telling a prediction like a 0. So what does 0 represents in this case? Zero is basically no. But we must do one thing. If I look into our labels, it is like a no tumor. We don't do label encoder in this case, right? Like converting S no. But still it's managing. Okay, since it's a deep learning model, even though you don't see, so it has a capacity to convert into a S2, so it can manage. So no worries. So if it's more than 2 classes, then you have to do it. 0, 1 anyhow it understands, but it's making a wrong prediction. So it happens because the model is not 90% or 99% right to expect the better results. You can try one more. This is normal image. Basically, you can see like no tumor, nothing. So let me save image as. Okay, so let me just upload. Understood how to make a prediction. It's giving like 50-50 chance only. Anyways, I'll try with a T. Okay, here it says like a 0. 0 means like a no tumor. Even in this image also like no tumor. If you look into this. But this had a tumor, it didn't recognize. Okay. You can try up to 100 epochs and you can again test your model with certain predictions, taking images. Understood? Is it clear? Same way, just do the task, whatever I have given related to potato leaf. This is prediction or potato leaf classification. Hope it's clear. Understood? Thank you. Thanks for joining. We'll catch up tomorrow and we'll do the NLP related stuff. I've already uploaded the notes.